Hello everyone and welcome. In one of the branches of chemistry, physical chemistry, we study how physical quantities such as force, motion, electricity in physics can affect chemical substances. Do you know that electricity can affect substances and cause them to change? Of course they can. In electrochemistry, a subset of physical chemistry, we see how electricity can cause a substance to undergo chemical changes. One of these changes is the chemical decomposition of the substance. Now, when electricity causes a substance to undergo chemical decomposition, that is, causes the substance to break down into its constituents, we term such a process as electrolysis. In this video you are going to watch, you will learn about how to define electrolysis, the mechanism behind it, the mechanism behind how it works, and the terms associated with electrolysis. Let's get on the way.
Electrolysis. I'll begin by saying electrolysis is formed from two words combined together, which are electro and lysis. Electro from the word electrons, while lysis, as you all know, means to break down or to loosen. Now, in this lesson, you are going to learn how this is done in such a way that a compound can be broken down by a flow of electrons. Now, what is the basic principle applied in electrolysis? In electrolysis, we find that a compound in the molten state or aqueous state conducts electricity and is decomposed by it. In chemistry, we find that these compounds, when they are in their molten or aqueous state, conduct electricity. That means they serve as a medium for passing current. And when this current passes through them, they tend to undergo a chemical change, which is decomposition. So they get broken down by this current that passes through them. Now, I am going to show you a glossary of the mean. The first time you are going to be hearing more often is what we call an electrolyte. An electrolyte is an ionic compound formed from an ionic bond containing ions, which when molten or in aqueous solution can conduct an electric current and is decomposed by it in the process. An electrolyte is the center of all we are going to be learning today in this lesson. Then the other thing we're going to have to be familiar with is what we call an electrode. An electrode is a rod or plate that can be small but not so small that it has a small cross-sectional area like your wire, where electricity enters or leaves an electrolyte during electrolysis. And it's important for you to know that reactions occur at the electrode and not inside the electrolyte. It occurs at the electrodes and not inside the electrolyte. And the electrode could either be inert or reactive. We're going to see what that means as we progress. Now, there are two types of electrodes. Remember, we said where electricity enters and leaves. The first electrode is the anode. The anode is the positive terminal, is the positive electrode connected to the positive terminal of the power source. If you are using a DC, direct current power source, oxidation, which is the loss of electrons, occur at the anode. Now, the other thing we'll talk about is what we call your cathode, which is the negative electrode connected to the negative terminal of the power source. reduction, which is your gain of electron, occurs at the cathode. Now we also talk about anions. An anion is an ion with a negative charge. During electrolysis, it is attracted to the anode, that is the electrode that the anions migrate to. So we'll call it anode. You see the word ODE here from the word electrode. Then we'll also talk about a cation more often as we go on. A cation is an ion with a positive charge. During electrolysis, it is attracted to the cathode because that is where the cation migrate to. The cathode is the electrode that the cation migrate to, so they are called cathode. Now I have a short interesting video for you that will better help you understand electrolysis. But before we go and join up with the narrator of this video, I want to introduce electrolysis to you briefly. Electrolysis is the chemical decomposition of an ionic compound brought about by passing electricity through the molten or aqueous solution of the compound. It is the chemical decomposition of an ionic compound that occurs when current passes through the compound, when the compound is either molten, that is melted, or an aqueous solution, that means the compound was dissolved in water to form a solution. Now this means that electricity is here in electrolysis used to cause a chemical change. A chemical change is a change where a new substance is formed and the process is not reversible. Move over to that short video done by Fuse School and explanation done by Matthew Tosh. I want you to pay attention to the visualization of the ions, the electrons, and the way they migrate to their electrodes. At the end of the video, I'm going to ask.
Electrolysis is electrical current flow through a liquid which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now consider putting two electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the two bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. From our lesson Behaviour of Metallic Structures, we know that electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily if a potential difference or a voltage is applied across it. This could be from an electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery, and this is what happens when current flows. Current is the movement of charge. In this case, electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electrical cell. The electrons will start to flow in the wires, and this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations and chloride anions. Anything positively charged in the liquid, in this case the sodium ions, is going to be attracted to the negative electrode. And anything negatively charged, in this case the chloride ions, is going to be attracted to the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron exchange happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind. It all depends on the liquid and what material the electrodes are made from. There is more detail about this process in our lesson Interpreting Electrode Equations. There are special names for the electrodes, which are usually metal plates with a larger surface area than a piece of wire. The positive electrode is called the anode, it attracts anions, and the negative electrode is called the cathode, it attracts cations. The liquid is effectively conducting electrical current. The only difference is that the charge carriers in the liquid, in other words the charged particles that are moving, are ions. If a liquid has free moving ions and can conduct like this, it is called an electrolyte. Remember that electrolysis can also take place in ionic solutions as well as molten compounds. The more concentrated that solution, the greater the ion flow rate. Ion flow rate can also be increased by increasing the potential difference or voltage across the cell. We'll be studying several examples of electrolysis in more detail in other lessons. For the time being though, here is a summary of the key ideas about electrolysis. Electrolysis is the flow of electrical current in a conducting solution or molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When current flows in an electrolyte, it is the ions that move and carry the electrical charge. When current flows in the electrodes and wires, it is the electrons that move and carry the electrical charge.